This video, we're going to determine whether an argument is inductive or deductive. Inductive means that we are making a broad conclusion from a small premise. So here's our premise up here. Our conclusion is broader than the information that we've been given. So this is the inductive reasoning. And deductive reasoning you make a conclusion that is smaller than your premises. Okay, so let's look at this first one. His past 4 at-bats were strikeouts, therefore his next one will be a strikeout. That is an inductive argument. So you're making a hypothetical conjecture about something based off of a pattern that you see. So inductive reasoning often is when you try and induce a pattern. And that's based off of the best information that you have. So we have to do that a lot. Every forecast that we make in business or weather forecasts or whatever are deductive reasoning. Last time that the pressure and the temperature and the wind and whatever looked like this is what the weather did. So we think that there's a good chance that the weather may do the same thing that it did before. Fresh fruit is expensive in the winter. This is January, which is in the winter. So these fresh strawberries will be expensive. That is deductive. You've started off with a big statement, a big premise that that fresh fruit is expensive in the winter. Then you got narrower to say it is winter, therefore the fresh strawberries will be expensive. Every coach must know his sport well. Steve Spurrier is a football coach, so Steve Spurrier knows football well. This is deductive. You can see it follows much the same pattern that number 2 did, only it's about coaches and specifically football coaches. And then Steve Spurrier is a football coach, so he must know football well. All right, let's look at this. This is already looking to be something that's a pattern to me. 7 plus 17 is 24. 43 plus 17 is 60. 41 plus 13 is 54. Therefore, the sum of 2 prime numbers is even. So that would be inductive. And it's actually not right because I could take 2 as a prime number plus 3 as a prime number and get 5, which is an odd number. You'd have to exclude 2 from the list of prime numbers that you're using in order to make that statement true. But this is not about the veracity of such a statement. It's just what type of reasoning was used. You started off with a few examples here, and you tried to make a broad generalization from it. That's called inductive reasoning. Practice makes perfect. Therefore, if I practice, I'll be perfect. It's deductive. Large premise, small conclusion, right? All US presidents have come from the contiguous 48 states. No person from Alaska can be president is the conclusion that I'm trying to draw. That's inductive. Just because it's never happened before and is a pattern that you see doesn't mean that you can draw the conclusion. I mean, you have drawn the conclusion from the pattern, but that's based off of available facts. If those facts change, you might have to change your conclusion, right? For any positive number p, the absolute value of negative p is p. Therefore, the absolute value of negative 94 is 94. This is deductive. That's a broad mathematical theorem, and you are picking a specific example of that. That's deductive reasoning. Okay, that's it for this video. Next time, we'll come back and talk about determining the validity of the premises and the strength of the argument and assessing the truth of the conclusion.